All right, so we left off with having this down payment on our general solution, and this is for this inhomogeneous equation. So before we move forward, a couple of comments are really important here. First of all, these first two terms are, again, the homogeneous part of the solution, denoted yh of x, and that corresponds to the left-hand side of the equation. And then these four terms here, which are our particular solution, yp of x, of course, corresponds to the right-hand side, our forcing term. So now let's go through and find the values of a, b, c, and d. And to do that, we have to go through the process of taking the first and second derivative of this and substituting it in. And we're going to do something that's kind of a cheat here, but it will save us some work. We're not going to actually use the first two terms because they are the homogeneous solution, and they will turn to zero when we take the derivatives and substitute them into the left-hand side. So I'm going to denote them as YH, but I'm not going to actually differentiate those terms because that's not really necessary. I'm just going to use the prime notation to represent taking those derivatives. All right, so now let's go through and first find y prime. Y prime of x, again, is going to have YH prime of x, we'll call it, plus a, that's the derivative of ax. Derivative of b is 0. And then for the cosine, we're going to have a negative 2c sine of 2x, and then a plus 2 times d. So plus 2 times d times the cosine of 2x. And then we'll find the second derivative, y double prime of x. Well, that's just yh double prime plus a negative, so we'll make it minus 4c cosine of 2x minus a 4d sine of 2x. All right, so now we're going to substitute all of these into our differential equation. So in place of the y double prime, we're going to have yh double prime of x minus 4c cosine of 2x minus 4d sine of 2x in that place. Then we're going to have minus 6 times our first derivative, which was yh prime of x plus a minus 2c sine of 2x plus 2d cosine of 2x. And again, that's from the minus 6y prime, and then plus 9 times our yh of x plus ax plus b plus c cosine of 2x plus d sine of 2x. And that must equal out to x plus the sine of 2x. There's a lot here going on, but you'll notice for starters that yh double prime minus 6 times yh prime plus 9 times yh, they're going to equal 0 because that is the solution of the homogeneous equation. So this term and that term and that term cancel out immediately. The next thing to do is take a look at constant terms. So if we look at constant terms from this, on the left-hand side, we've got a minus 6 times a, and then we are going to pick up a 9 times b. Again, that's from these two terms here, 9 and b. And that will equal out to 0 on the right-hand side because there's no constant terms over there. So we'll actually write constant behind that. Now let's take a look at our linear terms, our x terms. So nothing at the beginning until we pick up a 9 and an ax. So that's a 9a. We don't need to include the x. And then that will be equal to 1, which is the coefficient on x on the right-hand side. So this is we'll call it the x term. Now let's take a look at the cosine terms. There's definitely more of these. We've got negative 4c. Then we've got plus, where'd it go? We got minus 6 times 2d is going to make minus 12d. And then we're going to have 9 times c. Well, 9 times c. And that is equal to 0 since there's no cosine terms on the other side. And now let's take a look at the sine terms. So sine terms, we're going to have a negative 4d. And then we're going to have a plus, actually a minus 12d. Is that going to be right? Let's see here. No, the sine term, we're not doing cosines, we're doing sines, sorry. So that's going to be plus 12c. And that's coming from this sine term here. Don't forget about that one. And then we finally have over here a 9 times d. And then that equals to a 1 on the right-hand side. So that right there is our system of equations that we need to solve. And you are welcome to use a graphing calculator for this, but it's really not necessary because you can easily solve this by hand because the values of a and b, you'll notice, they are uncoupled or separate from the values of c and d. There are no overlapping of the variables here. So you can kind of solve these both independently. So we'll do that in the next video.